Here comes our first question. Test in part 1 for x-axis symmetry. So how do I check test x-axis symmetry? Read the description above for x-axis symmetry.
You replace it with the negative x.
No.
Negative y.
It's always the opposite.
Oh.
We replace y by negative y. Replace. Okay, so first take down the equation here, copy it down. And I make this guy, there is only a single y, and I'm gonna make it negative y. Okay? Alright, and stop and think. This is the result now, intermediate result. We have the freedom to multiply both sides with any number in an equation, right? So you can multiply both sides with any number. You can factor negatives out if you like. So you know the operations available to you. You can add things with any number, but you don't have to here. Is there any way possible that you can go back to this original equation with some trick? Such as, I see negatives everywhere. Why don't we multiply both sides by negatives, huh? Take parentheses of both sides and put minus in front of them. What happens? Minus and minus makes positive, right? And minus of absolute x, oh, this was minus x, right? So minus of minus absolute x is positive absolute x, and negative of minus 6 is positive 6. So what we obtained here is y equals absolute x plus 6 when I simplified it. Now compare the new equation versus original one. What was the original one we start with? Y equals negative x minus 6. Are they the same or different?
Different.
Are they the same? Compare the right sides. I mean, I have a match on the left. Y is y, but these are not matching. No match, right? There is no match here, so we say no match. So there is no x-axis, no x-axis symmetry. Okay? Is it clear? Is not symmetric with respect to x. How about y-axis? I retry this now for y-axis test. For y-axis, we replace x by negative x. Here is original. Is y equals negative x minus 6. Right? And I take and replace this x by negative x. So we get, once we replace it, it becomes minus absolute x. Minus absolute minus x minus 6, right? I'm just taking x away and putting back minus x. Now here comes the question. Can you make this back to original? This is new now. It looks different, but remember, you have some tools available to you. For example, what happens if you have a negative sign of anything, an apple under absolute value? what happens to this negative sign? You can remove it, wipe it out. Absolute value cures all negatives. This is actually what's going on. You have actually -1 apple there, and I can break absolute values into two pieces: the absolute value of the -1 and absolute value of the apple. An absolute value of -1 is +1. So the answer is just absolute apple. So in short, what I'm saying is, when you see a negative sign under absolute value, you feel free to wipe it out. Okay? But this is wrong. Don't do this. If you have a minus absolute x, can I say, oh, this minus will turn into positive and x will come out? Can I wipe those absolute values clearly off, entirely off? Yeah, the minus is gone, I know, but can you move the absolute value sign around x? Yes or no? No, we cannot remove the absolute values. Why? Because we don't know if this is positive or negative. Do you know it? Do you know the value of x? Maybe it's -5. What if this x was -5? Then the answer will be -5. Can you get a negative answer out of an absolute value? No. So the only thing you can do is, you can only wipe off the negatives inside the absolute value, but still x must be present with those two vertical little bars, absolute value signs. Okay? So what I'm saying is, we can wipe this off and get it as minus absolute x minus 6. Now, is this a match? Compare the new equation with original one. Did we go back to original equation with a little trick? Yes, we did. So we say the equation has y-axis symmetry. Okay? Let's go ahead and pick it. Is symmetric with respect to y-axis. And the final one. We need to test for origin symmetry. Oh, can I say it's not symmetric directly because one of the symmetries didn't work? No, don't trust your earlier answers, because there are some graphs, they are not x symmetric or they are not y symmetric, but they are still origin symmetric. Okay? So we still need to go test in part 3 with regular steps for origin symmetry. And how do we do this? We not only replace x values by negative x, but also we replace y by negative y in the equation y equals negative x minus 6. Alright, I replace x values. This is coming and replacing x, and also this is coming in and replacing y. Let's see what we get. Negative y, absolute negative x, and minus 6, right? Agree? Look, I just made each letter, this and that, into negatives. Alright, now work this out. What is the original? Maybe keep the original here. This is your objective. Try to get back to this thing. Can you make this like that? Yes or no? look, I can make this absolute x minus x. So we have a match here and there with these two. However, this is not matching. This is not match. Purples won't match. Well, you can multiply both sides with a negative and flip signs. Yeah, I can flip signs, but when I flip signs this time, these sides match. However, these two won't match. Positive absolute x and positive 6, right? While you're fixing the left side, the right side is imbalanced, right? It's broken. When you're fixing the right side, the left side is, it's never gonna align. It's never gonna be the same with the original, right? So we say there is no origin symmetry. This one. All right. Okay. Let's see what else we have. Why don't you try this on your own for a couple minutes? Let's take a look at X symmetry. What do we do? Tell me the method.
You replace y with negative y.
Right. I take this y away, keep the x the same, and put it back as negative y. Now at first, in the first step, I see it's different. I feel like, oh, this is different. They are not matching. But really, try to compute and apply the rules of math you know so far. Like when you multiply a negative number by itself, what happens? Take negative 3 and multiply by negative 3. It becomes positive. It's the same for negative y squared. It's double negative y, that means. And when I multiply negative with negative, it turns into positive. So it's actually just the same as positive y squared. So this thing actually equal to x squared plus y squared equals 7. Original and new. Are they the same? Are they the same? Yeah, they are. So we have is symmetric in this case. Alright, how about y symmetry? You're gonna repeat, isn't it identical? You're gonna repeat the same thing for x now, for y symmetry, right? I'm checking y-axis symmetry. So I'm going to take this x away and put it back as minus x. But that square around x is gonna save us again. And it's the same as negative x times is negative x is positive x squared. Y never change at all, equals 7. So same, right? Equivalent. So we go ahead and say this thing is y symmetric as well. Well, if you have an equation which is both x and y symmetric, then you can actually answer part 3 right here. It's already origin symmetric. Okay, but I want to test it anyways. For origin symmetry, what do we do?
Replace x with negative x and y with negative y.
Yes, both variables needed to be replaced now. But even I replaced them, still they have squares and they will make positives. So it's the same. So it's just 3-second verification. I do have origin symmetry as well.
So does that work out all the time?
Every time if you have part 1 and part 2 correct, x and y symmetric, then yes, origin symmetric comes automatically.
But if you don't have x or y, then does
We cannot say that. Yeah, if one of them fails to be, or both of them fails to be, there can still be an origin symmetry. Because take a look at this one. This is a picture equation, graph you're familiar from last time. Who can name the graph equation of this graph? What function does have this graph? One of the 8 main functions. 2.6. This is y equals x cubed. Yes, it's x cubed. Does it have origin symmetry? Yes. Take a point and connect it to origin and go all the way the opposite distance. Yes, you will find another point there. So it is origin symmetric. However, it doesn't have x or y symmetry, because if you had x symmetry, you would expect a point down here, right? If you had some y symmetry, you would have expected something on the left side, but they're absent. So this is not x